So as you are for sure aware of, this is a mini course in sort of the framework of InPlaLabs, a transnational network of integrated planning labs. And I'm here in the as a partner in Urban Calculator. It's a firm that we started a few years ago, but I'm also a professor at Chalmers University. And in a way, Urban Calculator is actually a spin-off of the research lab that I lead at Chalmers. So I have kind of two hats, if you wish. But today I'm actually mainly sort of presenting as a partner to this project from Urban Calculator, a spin-off company from Chalmers. But I will explain a little bit more. And we will talk about this tool. Urban Calculator is a tool to do integrated analysis of centrality, accessibility, mainly sort of focusing on supporting urban design at early design stages. Here you can read more. I will share this presentation later on through Nadia, and then she can distribute it.
Sorry for this.
Yeah.
Are you sharing?
No, maybe I'm not sharing. Wait, sorry.
Okay.
Wait.
I'm not seeing.
Yeah. Wait. That was an important part of the whole thing. Let's see. Where do I have my share button? This is okay.
It's in the board.
Yeah.
The green one.
Here. Yeah. Sorry for that.
No problem.
I will share my whole screen. Now you see it.
Yep,
Right,
yeah.
huh?
Great, thanks.
Good. So this mini course, considering Urban Calculate, will then inform you how you can use the tool doing centrality accessibility analysis. And as I said, mainly aiming at urban design at early design stages. And the company is, to introduce it a little bit, let me see, is as I said, a startup, a research-based startup, a spin-off from the Spatial Morphology Research Group that I lead, SMOG. It's a design support tool that quickly does analysis in, let's say, as part of the design process. So it's not that you do a lot of analysis and then in the end, at a certain moment, you do an evaluation of your design, but it's actually part of every stage, every sketch you make, you can actually get feedback from the tool in terms of, okay, what if you add a street, how does accessibility change? How does centrality change? And I will talk you through the whole thing. Let's say why we want to do this, why this is important, etc. But that's in a nutshell, let's say what we try to do. It's both me, Lars Marcus, Jana Stavroulaki, and Jane Bobkova, who started the company a few years ago. And we have Evangelos Vafeiados in the team at the moment. And there is a website, you can read more later on. And when we sort of started this, sort of working on this tool, the prior aim was to bring research expertise back to practice and to make it possible or easier to apply an evidence-based design approach as an integral part of urban practice. So that was kind of the main goal we had. And as I said, we wanted to sort of go from analysis as being an end product often of a design process. So you have gone through the whole design process, you have come to a solution, and then you do an evaluation or an analysis, but making it an integrated part of the design loop. So that's what we were sort of aiming at. And part of the reason of doing that has to do with what is called the McLeamy curve. And in a way, what this curve or this diagram tells us is that early on in a design process, you can make changes easily without big costs. So that's the moment you want actually to be informed whether your solutions or your ideas live up to the aims you have set or the goals that are set by someone else, your client or a politician or and the later you are, let's say, in the design process, so time goes, the more difficult it is to make changes simply for the fact that it becomes costly. Yeah, so you have already done a lot of investment in the design process, and you cannot sort of go back too many steps. That would be very costly. So this is kind of to avoid this. You have to get feedback or have evidence from a tool like Urban Calculator or many other tools that are out there. Feedback on your design decisions and make these decisions wisely and based on evidence. The analysis that are embedded in the tool, they are based on the solid research that we have done in the group, but also builds on what many others have done. And so it includes those spatial variables such as street geometry, the street layout, building density, that are important, we know are important, and we have, let's say, evidence for that they are important for pedestrian movement and all kinds of socio-economic processes in cities. The analysis engine, so kind of the motor on the back end, is the Place Syntax tool, PST. It's a plugin of QGIS. And that tool has been out there and tested and used within research, within practice for many, many, many years. So it's both, let's say, a solid sort of empirical foundation, and it's a solid technical foundation, so to speak, that are in the back end of Urban Calculator. And then Urban Calculator itself, you could say it's actually the user-friendly interface that makes it easier for practicing architects to conduct very advanced spatial analysis. No hassle with data, and you can just immediately start using it in a very design sort of oriented manner. And we will test, and you will see. Let's put this away a bit that I can see my own slide. Let me see. So as I said already, it's kind of having this engine on the back end, PST, which normally is used as a plugin in QGIS. The Urban Calculator then makes it possible to actually, without having GIS expertise, to anyway do this kind of analysis. And we know that in a lot of firms, let's say in private firms, but also let's say municipalities, they don't have this expertise, or this expertise is let's say a bit further away from the people that do the design. So it will take a lot of time to sort of ask questions to the GIS expert, and then you get an answer, but then actually you were already you went on with your design process, and the answer comes a bit too late. So it's kind of allowing the designer to actually execute these analysis without the hustle of knowing GIS, and also which we have sort of noticed on the many years that we have collaborated with private firms and municipalities, that especially also the data processing and all the questions connected to that is kind of putting a threshold of using analysis in your design process. So it becomes a sketching tool in this way. So what normally was a very technical analytic tool becomes a sketching tool. And then you can do a lot of iterations and arrive at your kind of optimal solutions related to the question or the aim you have set for your proposal. I think you can also put this away, right? It's a long time ago. Let's say we don't use that so often anymore, the Zoom. Okay, so in a nutshell, it's a user-friendly tool. It makes analysis part of the design loop. I've said that now many times, and it saves a lot of time. Partly, let's say, not communicating with the expert, maybe normally doing these analysis, but also literally money if you have to actually buy in an expertise from outside of either your company or a municipality. We have established, since we started, I think it's 3 years ago now, established collaborations with municipalities in Sweden. And we have been working also together with other cities, but let's say this is more that we test with them in certain projects. But these that are mentioned here, they actually have licensed the tool and are using it on a daily basis. And we also use it a lot in teaching. Because it allows students that at the bachelor level, for instance, have not been introduced to GIS to anyway use this kind of tools and make them understand kind of complex theories that I will touch upon a little bit in their hands-on design exercises. And that sort of is a way to let them learn by doing also, which is very, very useful in the teaching environment. So we use it to at bachelor level, at master level. We also actually have quite a lot of, like this one in a way, demonstrations and professional trainings for practitioners. We recently had one with 50 participants from different Swedish municipalities. So it's both, let's say, very, very fruitful in teaching and in practice. So to sort of introduce you to the tool, I first want to introduce you to some fundamental principles behind the tool to be able to understand, let's say, let's say in what sense it could be helpful in your practices. So one thing is that the tool models urban space based on, I mean, that's kind of the central thing. It's based on the configuration of the street network. So how the city or each place in the city is dependent on its position in the whole system, and especially in the street network as a system. And that creates kind of potentials for different locations, whether they are very well connected to all other places in the cities or whether they are rather segregated. And both can be good qualities. So it's not about sort of good or bad. It's just to understand what does these characteristics mean for what we can expect for activity in this place. Let's say a square that is located in a very central space has other potentials than a square that is not so well integrated in the city. It might perform as a local square instead of being the square, the central square of, let's say, Nicosia, or in this case you see Gothenburg on the maps. And to be able to do that, you have to do let's say these analysis based on space syntax theory are done on different scale levels to understand actually the performance of each and every space in the whole city or region, depending on which model you are working with. So you can do this analysis on very many scales, and I will come back to this a little bit, but this is this is very, very key to how the tool works. And this centrality that I talk about, so in a nutshell, how every street is connected to all other streets, we know from earlier studies done by ourselves and by others that it has proven to correlate with pedestrian flows. And so if you see in this image here, if each of these dots represent a street, then if the street is in the center of its connection, so it's kind of that street is connected to all, let's say, many other streets in short, let's say in quick steps or in few steps, then you can expect more people to be there. If you are on the edge, let's say, of such a system, such a network, like on the image on the right, you can expect less people to be there, for the simple reason that you don't come to that place passing through to somewhere else. And if the model is very small, so if you do this analysis on a very small town, it's relatively easy to just look at the map and understand this. But when cities become bigger and you want to understand the centrality and the differences in centrality for the whole city, all these streets there, it's very hard to sort of to evaluate that by just looking at the map. Then these kind of analyses are essential that I will show you. So it's also important to understand that what we are modeling in the urban calculator, similar in PST, let's say this plugin I talked about, is structure. So what you see on the right side, and then we have these measures of centrality that inform us about the potential for certain processes to take place. So we get an indication of what might happen on an image like on the left, let's say where all these people are walking. Let's say, where do we have a busy street and where do we have a calm street? It's not a one-to-one relation. It's not, I mean, we have the strong correlations, but it's still important to sort of to mention that what we are modeling is the structure, the physical structure, and what kind of characteristics that has. And as I said, it builds on the space syntax theory, especially the theory of natural movement. And what that theory says is that to understand pedestrian movement, or how pedestrian movement, let's say, is initiated, or when it can we expect a lot of people co-present in the same space, can be a street or a square, depends highly on street configuration. So how the streets are connected to each other, which we then can measure through centrality. So if the centrality gets higher, we can expect more people to move. So there's a direct error from the street configuration to pedestrian movement. And from that, let's say, to all kinds of other processes. Where do we find, let's say, economic activities, for instance, is also highly dependent on pedestrian movement patterns. So there's a lot you can sort of you know through the understanding of pedestrian movement. And there is also another variable here, which is called attraction. And for instance, I mean, a very rough attraction is the level of density, but also land uses are sort of put here on this part of this diagram. And attractions are also dependent on street configuration. So often in the very central locations, we have higher density. So there's also an arrow there. Then the pedestrian movement is dependent on attractions also. So if we have a high density or many different land uses, we can expect actually more pedestrian movement. And if we have more pedestrian movement, there is an interest for certain land uses to be located there. So there is an arrow back. And this becomes a multiplier effect. This kind of is independent from the street configuration when let's say this multiplier effect kicks off. But it started all with street configuration. And this relates back on the other side of the image. You see the different layers of when we describe the built environment. And so the layers of urban form, where you see that we have topography, we have streets and plots, public space, buildings, land uses, and they have different paces of how they change through time. So if we look at the attractions in the theory of natural movement, it's the upper two layers. They change relatively quickly, while the street configuration changes much, much slower. So the street configuration is kind of both because it sort of influences pedestrian movement and attraction and not vice versa, but also because it's such a slow variable, it's a key one to carefully design, because if we put it somewhere, it will be there for many, many, many years ahead. While land uses, they come and go. So there's a quicker pace of change. This is important. So it's in a design process, it's important to really have a good understanding of where to put the streets and how does that impact all the rest. As I said, but I put here, let's say, the details. PST is a plugin for QGIS, and PST is also the back end of the urban calculator. This is important not only because it has been technically tested for many years, and that makes Urban Calculator a sort of robust tool, but also if you use Urban Calculator in your design process, you can export your files, import them in QGIS, and continue working with them using PST, which has exactly the same algorithms and everything in the back end. So this is also to ensure a smooth collaboration, you could say, or interoperability between QGIS and Urban Calculator. Then what analysis can be performed using the tool? There are kind of 4 groups or types of analysis. We have centrality. I talked a lot about that already. So you can say, you can ask the question and get an answer. How central are certain places in a city or a region? The second one is accessible build density. So how densely built are certain areas in a city or a region? The third one is accessibility to services. So how many services are around you and how are they distributed? And the last one is proximity. How close is the nearest service? So these are the 4 sort of groups of analysis that can be done using Urban Calculator, and I will walk you through. Just to say, if you have questions, you can we are not that many, so just speak out and ask or put something in the chat, then we can take them while I'm going. So the first one, centrality, and I talked a lot about that, but we have actually 2 measures for that. But in first instance, centrality is an indicator of the flow of people one can expect in each street. So that's the kind of the core, why it is important and why you want to understand this. And it's based on the position of that street in the whole network. So you can say how, in a way, the question that is answered is how integrated is the street and how many people can be expected to walk there. So it's an indicator. It's not a one-to-one, let's say. It's not sort of a guarantee that if you have a high centrality, there will be many people. But there is a high probability that there are more people in streets with a high centrality. That's the way you have to understand it. And then we have 2 measures here. And I think most of you are familiar with them, but I will still explain them because maybe there are a few people not so familiar with these measures of centrality. We have, on the one hand, angular betweenness centrality, which tells us which location is part of the most transit trips. So if you walk or drive from every location in a city to every other location, there are certain streets that you always or more often pass through. And this passing through is what the betweenness centrality informs us about. And then we have, on the other hand, angular closeness centrality, also sometimes called integration. And that is a measure that tells us something about the distance from place A to all other places. So how easy can you access all streets or all public spaces from one location? And you do this for each location or each street segment in the city, and then each of them will have a different level of this integration or accessibility to all other street segments. And we use in Urban Calculator, we use angular distance to do these. You can also do it by topological steps or topological distance, but in Urban Calculator, it's angular distance for the reason that we use the road center line map. And if you have questions about that, you can ask them later on, because this becomes otherwise a bit of a too technical discussion. And to just give you a few examples, so between a centrality, as I said, how often a street is part of the shortest path between all other streets in the network. And you see the results here. The darker blue colors have higher betweenness centrality. And in this case, I show you what is called the motorized model. We also have a non-motorized model. So here you see the motorized model, and it includes all the streets where the car has access. So including highways, but not including the pedestrian paths in the park. And the high betweenness centrality has proven to correlate with traffic and public transport flows. And here you see one example of a street with a high betweenness centrality in Gothenburg, in this case. You can do exactly the same analysis, but using, as I said, the non-motorized street model. And in this model, we include only the path or the streets that are accessible for pedestrians and cyclists. So the ones that are excluded, for instance, are the highways, because you cannot walk there. So they are not part of your network model of, let's say, it's not a path you can choose. And high between-ness centrality for the non-motorized street model has proven to correlate very highly with pedestrian flows. And here you see again an example of one of the streets in Gothenburg with a high between-ness centrality. And as I said, you can do these analyses on very many different scales. That gives you an understanding of, okay, the betweenness on a local scale is high, meaning that that street has an important passing through function on the local, in a neighborhood, for instance, if you do it on a 1 kilometer radii or radius. If we do this on 30 kilometers, we get the paths that are important for the regional through movement patterns. And often that becomes, if you have the motorized model, it will be the highways, most probably. And that's what you see on the map here on the right. It just picks up the highways. Then we had betweenness I talked about now. Then we have angular integration or angular closeness centrality. And that's to measure how close a street segment is to all other streets in the network. So in a way, how easily accessible and central that street is. And you see here, again, you can do this from the non-motorized and for the motorized street models. In this image, it's an example of the non-motorized. And it highlights city and neighborhood centers, depending on which scale, which radii we use. And the high angular integration has proven to correlate with clustering of local markets and mixed use areas. So where the areas are red, the streets are highlighted in red here, we have a high centrality, while the ones in blue have a low centrality in terms of angular integration. And then you can do this, as I already said, both betweenness and closeness centrality or angular integration. You can do the analysis on different scales. And you see here two scales, 2 kilometer and 5 kilometer. And in case you identify high integration clusters, both on the 2 kilometer and the 5 kilometer, we know that we have actually, it's a description of a city scale center. It sort of keeps to have high centrality throughout the scales. While you also have centers, and you see them here, that have a high integration on the 2 kilometer, but they drop a lot of centrality on the 5 kilometer. These are typically local centers. So they have another profile, if you wish, in terms of the type of center. So this is the way you can use these analysis across scales. Oops. So here we have, let's say, the two betweenness, the two centrality measures betweenness and the angular integration, where the angular integration sort of highlights places, local sort of clusters, while the betweenness centrality highlights the city structure. So they're very complementary. It's important to look at both. For instance, why is it important to look at both? You can have a high betweenness without a high integration. That is typically a bridge. And you see an example here. Sometimes you have a high betweenness in the street and a high integration, and this typically is a busy urban street. A little bit about the empirical support. As I said, there has been done many studies by many researchers in many different universities. We at Chalmers have done a very sort of large pedestrian survey. In both Amsterdam, Stockholm and London, and we went to many different locations. Here you see an example of London. So we went to, 22 neighborhoods from very high dense to extremely low dense areas, and did a pedestrian survey. So we counted how many people walk the street and correlated that with the centrality measures. So here you see examples of the different streets we have been in the different cities. And I mean, as I said, these were villa areas, city centers, modernistic areas from after the Second World War, with very spacious but high-rise areas. So all kinds of typical examples of European cities. And in all these areas, we calculated how many people walk the street in the different streets in each neighborhood. And what we found is that the variation of the pedestrian movement is highly explained or very well explained by street centrality, while the volume is explained by density and centrality in combination. So centrality and density were shown to be the key variables. There was a bit of influence by the presence of a public transport stop, but that was kind of a minor it gave a little bit more explanatory power to the model. The main variables were the two centrality measures and density. And that brings me to density. So now I sort of covered the first type of analysis that is embedded in the urban calculator. The second one is accessible build density. And here we build on the model that is the space matrix model, where you use several density measures. So not only one, not only population density or floor space index or floor area ratio, that kind of all tell us something about how intensely used is a piece of land. It actually also looks into the coverage of an area, which is called ground space index. And those in combination, that's what the space matrix has put forward, those in combination tells us something about the typology or of the block or the neighborhood. And you see three examples here: a high-rise area in Berlin, a block structure from Barcelona, and an older urban pattern from Amsterdam. And they all have the same floor space index or floor area ratio, which is typically used, let's say, in urban planning and design. But as we see, they are very different in nature and character, which is explained by the difference in height and the difference in this coverage. And by knowing the coverage and the floor space index, we actually also know the height. So this set of variables that are linked to density is what we have identified as important for the urban calculator and is embedded there. And we do not calculate in urban calculator FSI or GSI per plot or block. We actually use accessible density because we know, let's say, what we are interested in with the tool is to give you feedback on how centrality, density, etc. affects different processes in cities, how they are used. And we have sort of come through a lot of research that we have done and the empirical evidence that it's accessible build density that actually plays a role. And in the image you see here on the right, you see the difference. So it's the same neighborhood. It's an area in Stockholm. And on the top, you see let's say the densities plotted on each block, and the same levels of floor space index that are depicted there. You see in the below image when you calculate it through accessible density, and accessible density is actually the thing that drives where people are, where most activities take place, etc. So it's that one that is embedded in the urban calculator. And the combination of density and centrality and integration, as I said, is highly influential for pedestrian movement, and for that reason also the expected mix of uses. So if both are very low, low centrality and low density, then we have a typical suburban area. When they both are very high, we have a typical urban area. And also these sort of edges that are shown here are interesting, of course. So if you have this map, then you can also look into the areas that have a high centrality but a low density, and those might have a high potential for densification, for instance. So this can be an interesting sort of combining these measures is interesting in many ways from a planning perspective. Then the third type of analysis or group of analysis is accessibility to services. And this calculates the total amount of services or attractions that can be reached within a certain threshold, walking distance 500 meters, for instance, and that's what we have embedded in the urban calculator. So how many people, how many schools, how many shops can be reached within this 500 meter? So it's kind of a description of the presence of society, if you wish, in the city. And a map of that looks like this. So if you have the streets that are visualized in red, they have a high, let's say, a high number of schools, people, or shops that you can reach within 500 meters, while the blue ones, but there you have a very low number, low amount of that. And then you can, how you can use this is actually to, for instance, highlight spatial inequalities. Is there an unequal distribution of resources or services? For instance, is there, let's say, some people have a high number of public services in their proximity, others have a very low number. Is that, let's say, the way we want to organize our city or not? I mean, so in first instance, it will just give you the map, which you have to reflect on. Is this inequality that we see here, is that okay? Or is that something that you should work on and do something about? The last group is proximity. It's kind of straightforward. So it's just telling us how far is a service. The nearest bus stop, the nearest park, the nearest school. So is it 100 meters, is it 500 meters, or is it 3 kilometers away? And this we know is important from a walkability perspective. Let's say we are willing to walk to school or to a bus stop if it's not further than. And then and often it's actually quite nearby. Things have to be to make us willing to walk to it. So there are many cities, many municipalities that have actually set these sort of indicators of or requirements that in Gothenburg, I know, for instance, that the requirement is that every citizen in Gothenburg has to have a park within 300 meters. So this could be tested through the urban calculator. And then you can make adjustments and you can recalculate and see if you sort of fulfill this requirement. And the map looks like this, but I have a few other examples. So for instance, in this case, we see how many public transport stops you have within 500 meters. Is that right, what I say now? Yeah, so this is actually one of the other ones. So let's look at this one. So here we have attraction distance to school and we have attraction reach to schools. So those are the two different types of analysis that we have embedded. So the attraction distance to schools says that how far is the nearest school? So do I have a school within 500 meters so that my kid can walk by him or herself to school? Or is it further away? And then the probability that I have to sort of, it will be either by bike or by car or public transport. So that's the map on the one hand. The other map shows you the attraction reach to schools. And that tells us whether you have a choice between 1, 2, or 3 schools, or is there only one that is nearby? So it gives you kind of an how many opportunities or how many variations you have of a school choice in this case. But you can have, let's say, we can replace school with something else, and then you can do also this comparison. So one tells us, okay, how far is it? Are we willing? Can we be expected to walk there? And the other one says, how many different choices do I have between, in this case, different schools? So it's interesting, again, let's say, to look at both, like we discussed earlier with the centrality measures. They tell us different stories, the closeness and the between the centrality. In this case, it's also important to look actually at both in many cases, because they answer different questions. Then to apply this in your design process can be done on different scales, of course. We put this here in the presentation because it's important to highlight that it's not only this high level master planning, comprehensive planning level that is where the tool is relevant. Actually, it's also relevant to on the street level. So I will just give you a few examples of that. So the most sort of straightforward way to use this is when you are working on more larger scale redevelopments. This is an example of an area in Gothenburg that is going to be transformed. They are changing a highway into a boulevard, making new connections, transforming an industrial area. So a lot of these big questions where the tool can be very, very powerful to see, okay, how many new connections do we have to make, and what over the old highway that becomes a boulevard, and how will that affect the distribution of centrality? How will it change the accessibility to green areas? All these questions, let's say, can be answered using the tool. But also you can use it on a more sort of urban design level, a development plan on a smaller neighborhood, and all the way to understanding what can I do in every street. So for instance, you can sort of identify what are the main city streets in my neighborhood where I might have activities on the ground floor. So I have to sort of have in my land use plan, I have to make sure that I allow for activities to take place along those streets. So it's kind of understanding what type of street you have also gives you the sort of the information to plan for the blocks to have allow for certain functions to take place and densities. So that's what we put here. And the same goes for, let's say, the type of playgrounds, local parks, let's say, maybe even maintenance, let's say the level of maintenance that might be required there. If you have a square with a lot of high central streets coming together, it requires another maintenance plan than for more local squares. So it goes all the way, let's say, from these larger scale understanding of the system to understanding also how a very local square, or let's say I should not say local, I should say individual square, independent if it's performing as a local square or an urban square. But it tells you about that individual space and how it should be designed, what land uses should be allowed, and even maintenance. And also, if you have, let's say, if you want to inform about where entrances should be located, how a block design can be sort of support this different centralities of the street. You see an example here of a design of a block where the block typology is adapted to the kind of the characteristics of the street surrounding it. And what you see here is that, for instance, the block opens up along the streets, the green streets here, with a very low centrality, and they are closed with more entrances where you have the high between-us street. So it's also sort of can inform you about the choice of building typology, the choice of ground floor activities, the choice of access points towards your courtyard, etc., etc. What do you say? Do we want to have a small break before I go to more? Let's see what comes here. So here now I step over to talking a little bit more about how to use it, just more hands-on. What do you say?
Yeah, I think we could have like 5 minutes break
Yeah,
and
yeah,
start again at 11.
exactly. Ah, that's a
Okay,
good
that
idea.
would be
Let's do
great.
that. Yeah.
Okay.
Hmm? You want to record? Yeah. Good. Let's continue. So it's a bit smaller. So I'd like to continue with explaining then how you actually use the tool. And I will also give you a demonstration of the tool in a minute, but that can, let's say, we have to see how that works on Zoom, because sometimes it's too slow and the analysis doesn't really like it. But so I prepared, let's say, I put everything in the presentation, and then we go to have a look at the tool itself live, let's say. But so it's a map that you can transform. You can actually transform the streets for the moment only. So it's not, you cannot add buildings, but you can add streets, remove streets. And you have, as you recall, when we do the centrality analysis, you can do that for the motorized or for the non-motorized map. So when you open, so you have the urban calculator installed on your computer, then you open a map, and here you see that for Nicosia, and there is a non-motorized model and there is a motorized model. So you open one of them. That's the first thing you do. Then you can analyze across scales. So you see here an example for the city scale, 5 kilometer, the local scale, 1 kilometer, and the neighborhood scale, 2 kilometer. And then let's say it runs, so you run the analysis for these 3 scales on centrality. You also, and it outputs then these maps. You can do comparisons about 2 scenarios or the current situation and a design proposal, and you can put them side by side. And all the measures that I have been introducing, you can, so for all these, you get a map, but you can also click on a street and get information of an individual street segment for all these measures. So you can know that, okay, this street has an integration of this and that. On the 2 kilometer, the build density on in terms of accessible FSI is this. The shortest distance to the school is that, and you can sort of click for that for each and every street. Let's say it's kind of an information of every street. And in the tool you also see, and I will show you later on, you can then also see not only the number, the absolute number, but also how that number is, let's say how high that number is in relation to the maximum value in the city. Because I mean, it's a bit hard to know, okay, an accessible density of 1, is that high or low in the city I'm sort of analyzing? So you get kind of a bar where you see how, let's say, relatively high or low that number actually is in relation to the city or the region that you are analyzing. You can also, so besides, you always analyze the whole city or the whole region, so the full model is included. But when you visualize, you can actually choose to visualize the results for the whole city, or you can define neighborhoods or project areas and get the results visualized only for that neighborhood. And that I will show you later on, that can be very handy, because sometimes, let's say when you are in the city center, all the centralities are very high in relation to the rest of the city. But within the city center, of course, there is variation in these higher values. So if you want to see these variations in a neighborhood, you need to have this so you have to define a kind of I think we call it site area or study area. And then you can actually only visualize that in itself. So that can be very handy if you have a defined project area in the city that you are working on. You can output the maps of let's say the results of the analysis, and that whole process is automated. You get a predefined layout of each type of analysis. It informs you about which model is used, so the non-motorized or the motorized network. It informs you which city or region the it is about. In this case, it's Gothenburg, as you see. It tells you which type of analysis is shown. In this case, accessibility to public transport within 500 meter. And then there is a small explanation both on the model that is used and this measure. You see the legend. And then in this case, there are two maps because when we did the output here, we wanted to show two design alternatives and how they perform differently. So this is the output, and for each type of analysis, you get, let's say, all this, making it very practical. Let's say if you want to, if you have done your tests, you can print this as a PDF package and share it with your colleagues. This is again, I've actually talked about that quite a lot already before our small break. So the between is centrality. How often is a street part of the shortest path to all other streets? That's the analysis you can do. You have the angular integration, and you recognize it now. You have these red clusters, which tell us something about these areas have a high integration, and we can expect more local markets here than in the areas that are yellow or greenish. We have the accessible FSI, accessible GSI, and you see that all the analysis results, they are put on the street segment. There is a reason for that because we think you have to, let's say in your design choices, it's the street in a way that holds, that's the space we experience when moving through the city. So there's a sort of a background for that. You can also look at the space matrix. It's now shown a little bit in its sort of, it's very flat, but that doesn't matter so much. It's a space matrix where you had the FSI and the GSI, the FSI on the y-axis and the GSI on the x-axis. So these numbers that you calculate here, they are sort of, they put as a dot in the space matrix. Then a little bit about the data that is sort of put into the tool. And the one that you have for Nicosia has all this data embedded. So the license always comes, let's say it's both the interface, it's the connection to the kind of the analysis engine, PST in the back end, and it's all the data that is required. And this data is then also checked and tested that it performs well. So for the motorized street network, that is always embedded. As I said, these are the streets that are accessible by cars, so including highways and tunnels. And we prepare this model often using official sources. But if they are not there, we use OpenStreetMap data. 90% of making the map of the motorized street network model is automated, 10% is manual checks. And you see here in black for Gothenburg is what we call the motorized network model. And then you see the yellow lines, that is actually the non-motorized. So you can actually show also, if you open the motorized, you can show the non-motorized as in a lighter color. You see also, you see all these green circles. Those are called unlinks, meaning if two streets cross, but they're actually not, you cannot go from one to the other because you have a bridge situation or a tunnel situation, then you have to add unlink. Of course, those that are existing are already embedded, but if you add streets, also unlinks have to be thought through. I will come back to this, but just to be aware that these green circles, that's what they are. And here you see then the opposite. So if this was the motorized street network model, here we see the non-motorized, the pedestrian street network model. And in the light yellow color, you see the streets that are not included, the highways in this case. So those are part of the motorized, but not of the non-motorized. And the rest of the black, all the black lines here are part of the non-motorized network. So be aware that there's a lot of overlap between the two. It's not so that So many of the motorized streets that are accessible for cars are also accessible for pedestrians and cyclists, of course. So they are present in both models. This one is also built on official sources and OSM data. In this case, it's 60% automated, you could say, but there is more manual check required for developing or preparing the data set for this one. And as I told you already before, this one is especially important when you want to understand pedestrian flows, location of services and social infrastructure like schools, healthcare centers, etc. Then the other data that is included is building data with heights, so that we can calculate the gross floor area, etc. It's attraction data, including both green, so parks are there, water areas, but also local markets, services, schools, and here actually many layers can be added depending on what is required. We use official sources or at times OpenStreetMap. Then I prepared design exercises. I will introduce them, and then we also go again. Let's say a little bit more a tutorial of all the all the buttons in the Urban Calculator. And after that, I think I let you play a little bit with the Urban Calculator for half an hour, and then we come back. And I prepared also some analysis myself, so we can talk it through. It would have been better if we would have been sitting in the same room, but that's not the case. So we have to do it with what we have and do it in Zoom. But first I will introduce you, let's say, two kind of design exercises that can help you to have something to work with when you are testing the tool. And the first one we thought was interesting is to look into the linear park in Nicosia. Here we see the map of Nicosia, the old part, and here you see the linear park. You see in very light green. And the idea is that in the exercise, you try to make the linear park a central place to meet for everybody in Nicosia. So that means we would like to have, let's say, a lot of accessibility to the green area. We ideally see a lot of streets passing over or through that have high between centrality and high integration. So that's kind of so you always, if you have the question, you have to sort of translate them. Okay, but what does that mean in terms of centrality, density? Maybe we would like to see, let's say, higher density even surrounding the green park. But let's focus on the street network. So do we need many bridges? Do we have to add bridges to guarantee a high integration and access? Which areas have most potential to become, let's say, the urban hub instead of having, let's say, like we conventionally or traditionally think of that the square should be a hard surface area? Maybe the green area in this case should be the core of the city. So how do we achieve that? If that would be the aim, how do we achieve it? And of course, adding many bridges will change the centrality a lot. But then the next question comes, which bridges should we prioritize to create the most impact? We can remove bridges again, and maybe it still works very well. So can we make an economic or feasible solution that has maybe only 2 bridges instead of 20 and still does a good job? So also that, let's say, you can first add a lot and see what the impact is, and then you can start removing and see, okay, does it hold, let's say, the centrality that I wanted to achieve, for instance, around a part of the park? So that's the first exercise I thought you could work with. And then you see here, I played already a bit and I will show you the results of doing that. In red lines, you see the streets that I added. And I just sort of, I don't know Nicosia so well. I don't know what is possible, what is not possible. So I really played around, just to be clear about this. So you add these red streets, and then you rerun the analysis, and then you can look at the results. I have done that. I can show you later, but I don't want to do that. I show it now because then, I mean, you should sort of test yourself a little bit. The second exercise is a very different one. So here you have to do interventions and change the street network. In the other exercise, we thought it was interesting to look into, there is an idea, maybe Nadia can say a little bit more about that, the campus area, where Nadia and her team is located currently, which is in the south, let's say the lower part here, the lower circled area. It's an idea to relocate that to the old city center. And then the question you could ask is, well, how well integrated is actually the current campus area in terms of its centrality, in terms of the density surrounding it, and how well integrated is the new proposed campus position? How easy is it to navigate to the current and the new campus by car, on foot, on public transport? So all these questions you can actually sort of analyze without doing changes. You just look at the current situation and run the analysis and try to interpret, what does this mean if we have, let's say, centrality this, centrality that, density surrounding the campuses, etc. So you get kind of an insight of the current situation. Nadia, do you want to say something more about this?
Yeah, I mean, I was just going to add the last point that you mentioned, that is a matter of interpretation of what does it mean to be located in this existing building in the historic core, which has different spatial characteristics than where we are currently located at Kalliporeos. So it would be nice to do a comparative discussion
Exactly.
on the impact of the relocation.
Exactly. Very good. So these two exercises we thought you can work on. You can pick also one of them. Let's say if you think I like the second one better, let's start with the second one. And then if you are done, you can go to number one. Or let's say if we meet, let's say in half an hour, some of you have done one and some of you have done two. It doesn't matter. But before I leave you to it, I have a few slides more on some of I mean, you got the PDF with the how-to, and it is very straightforward how to use the tool, but I still thought I will just walk you through a few of the sort of steps so that you don't get lost. So here you see the interface of the Urban Calculator. So if you have installed it, probably you have already seen it. When you start off, you have to go to File and choose New, as you see here. And then you get this window where you can choose between the non-motorized, the non-motorized and the motorized model of Nicosia. And we will choose the non-motorized. And then you open, and then you will get this, what you see in my background here. And then you see also all the layers that are embedded here. You see in red new streets, in black the existing streets. You can also remove streets, they become very light gray. And removing is just selecting it and deleting it. New streets, I will show you how you will add them. You see the unlinks, I talked about those. Those are the green circles. You can, if you click on this one, you don't see them on the map. So if you think they are annoying, you can just let's say unselect this one. Local markets are embedded as a data set. The schools are embedded as a data set. Public transport stops. The motorized street network, as I said, let's say, although we opened the non-motorized, you can actually show on the map the motorized. It becomes a light colored, I think in gray line, that can be handy for understanding or let's say finding your way in the map. You can show that one. Then we have buildings, and we have parks and green areas that you can sort of visualize or show. Then on what is below here, which is called study areas, I talked a little bit about that already, but I will show you more. So this can be very handy, especially also now. Actually, if you do exercise 2, for instance, select the area where you have, either you can do 2 study areas for each of the campuses, or you can make one where they both fit in, but you don't include the rest of Nicosia. You always have, let's say, in this study areas window that you see here, you always have the full map. So that's by default, it's always there. So, and then on top of that, you can add with the plus, you can actually add new study areas, and you can give them a name. So city center, campus area 1, or campus areas, you just give it a name. And then it will be here, and you can, every time, you can sort of click on them and you either see the whole or you see your study area. So if you make a new one, it's sort of this window pops up and you can just change the size of it in the way you think it fits your purpose. So that's very easy. Then to run the analysis is this button in the tool. And then what you get is again a pop-up, or this pop-up window. And there you see all the types of analysis that we have been discussing. Network centrality, and you see between this, you see integration on the different scales, build density, accessibility, and then further down is proximity. You can either click all of them and all the analysis will be done, let's say, simultaneously, or you click the one that you are most interested in. So if you only want to see between a centrality 5 kilometer and angular integration 5 kilometer, you only click on those 2 and it will only run 2 analysis, and your result will also only include then these 2 analysis. Sometimes, let's say for time, for the sake of time, but actually it goes very fast, so that's not so important. But it's also a bit annoying if you don't need the other maps, that you always get all these maps. So just for your own sort of ease, sometimes it's let's say if you don't need them, just don't include them. You can change the color of the maps. So if you have done the analysis, a new window pops up and it shows immediately there is a sort of a default setting for how these maps are colored or visualized. And you see then the legend. So in this case, it's a centrality. One of the centralities, I think it's between a centrality. And the legend is that the 1% highest means that, let's say, 1% of the let's say the streets, 1% of the streets with the highest values of centrality are visualized in the thickest red color, and then it goes all the way down to the lowest. But you can change from red to blue to spectral. So those are the 3 visualizations that we have embedded. Let me see what I have more here. So that's that. Then, yes, what can be practical also if you have, because every time you make changes on your core map and you rerun the analysis, it opens up in a new window or a new tab, I should say. So you can have many of those. And then sometimes you want to have, let's say, that they all zoom in a similar way, because otherwise it's hard to compare. So what you can do is you can copy the viewport from one of these windows and apply it on the others. So that's just a very practical thing as well. Then you can export the analysis maps. So you choose from File, Export, and what you get is a PDF with all the analysis that I showed you already before. Then, yes, important to, if you want to design or just add streets or remove streets, sometimes it's practical to have a kind of a sketch or a drawing in the background. Especially you want to have it if it's a big area that you have already been sketching on, then you can actually import an illustration as a background image, and you do so by, I have to see how I did that. I think it's over here. I should have put a circle here. You see on layers, there is this button. Then you get this pop-up window, and there you can pick an image that you have, a JPEG. And then you can adjust the size, you can position it where it should be, and draw on top of it. Drawing then is using this button, the pen, and you just draw lines. It always snaps, so you cannot do it wrong. It always snaps to an existing street, so the network is always, let's say, complete, not because otherwise there's always a risk that you think you draw it on top of the street, but actually it didn't really connect, and then the whole analysis that you will be doing will show you wrong results. That doesn't happen. It always snaps to the nearest. You can also remove streets, as I said. You just delete them. And by default, you get these unlinks. So as soon as you start drawing and you cross, actually, if you can draw very long lines, if you cross other streets, it will add unlinks. Many of them can be. You can think of this as annoying, and that's completely fine if you are annoyed by that. The reason that we have done this is that we want you to be aware as a user and take sort of conscious action to remove them or keep them if it's indeed a tunnel situation. Because the risk otherwise is, if we wouldn't have done that, is that you forget about these unlinks, and they are very important to put them right. And you can actually remove them by this button here. And that goes very fast, so it's not so annoying, I can promise you. Then for the export that I talked about earlier, there's this button, then you have this pop-up window, and you can actually choose which of the analysis maps you want to put in the export. You can choose one, or as a maximum 3 maps. So it could be the existing situation, scenario 1 and scenario 2, for instance. And those then are presented as a PDF, and the maps are put side by side. So that was all. Then I actually, let's see if I can open the Urban Calculator. Here we have it. I will go here. You see my window still in my screen. So now I am in Urban Calculator. So this is the icon. In my case, I've opened it. And then the first thing you have to do is to open. And you see here, Nicosia non-motorized, motorized. You open it and then you get this map. And you can zoom out. So this is the whole model that we have. And if we zoom in, we see, I have to put this somewhere else, sorry. We can pan here, we can go to the center. And you see we don't have buildings on the other side here, on the Turkish side, because we didn't have the data. We can put on the water, for instance, and the green over here. We can take out the buildings. So we see the street network and the green areas. Well, it becomes very clear. We can have the local markets where they are located, the schools. See, so this is really easy to navigate. This is what I showed you already. You know, when you can add a background image, if you have a sketch or something. Here we have the study areas, and actually I prepared a few. So if I go to the city center, the linear park, my study area, or the full map. You see? And this is very, I mean, and this you should do, let's say, immediately. You have to sort of start making these study areas, because then if we export or if we make analysis, it will also have this set of study areas that you can zoom in to. And the drawing, so we can actually, if this would be repaired, we can make new connections. This is how we draw. I just click, you see it, how it snaps. You see where it snaps? It gets a small blue circle. So we can just add, repair all these broken connections, and we could rerun the analysis. You see, it's very, it goes very fast. Can go, and I will also show you if I would sort of draw a long line, which can be actually, so you don't have to draw all these small lines, you can draw a long line, and you saw all these unlinks popping up. If I don't want them, I just click this button and I remove them again. And there we are. Then if we run the analysis, it was this button. And here you have this window where I can actually choose to run all of them. I click on them. So you see all of them will be running. Or I can say, no, I don't want accessibility. I don't want proximity, not build density. And I only want to see Angular, centrality 5K and this one. Or maybe I will only take these 3. Then I run start. And it starts running the analysis. And a new window popped up. And you see here the results. I can go from the results for the 1 kilometer, the 2, and the 5. And if we go to the full map, you see it sort of shows you everything, the 5K. And if we now go to the linear park, it only shows you the visualizations of the linear park. We can go to the city center. You see? So this is the way to go. I think you know enough to start working a bit. Let's stop sharing. Shall I actually show you the, let me see, the exercise again? To just remind you. So exercise 1 is to work with the linear park and try to create, first you could identify, let's say, okay, how is centrality distributed along the linear park? Are there locations that already have a very sort of, that the park is not only a place to sort of relax and be in nature, but maybe also a important meeting place. So a lot of pedestrian movement passing through in both directions. Can you, and if you have, see how the current situation is, can you improve it at certain locations where it's maybe lacking, or can you boost it where it already has potential by adding new connections? So that's one exercise you could do. And the second exercise is this interpreting what are the consequences of moving the campus from this location to the old core or old center in terms of well, navigation, having access to it, how many people or activities are already surrounding that. Sort of use the tool sort of to characterize the two different neighborhoods and what the pros and cons are.